So the first example of balancing equations that we're going to go through today is the combustion of glucose to form carbon dioxide and water. And we've got the equation written there. So there are certain steps that we can take to make sure that we balance equations correctly. And the first step obviously is to write down the reactants and products. In this case, we have glucose plus oxygen are our reactants, and they form carbon dioxide and water. So there are our products. So now we have reactants forming our products. So the next step is to make sure that we're balancing the number of atoms on each side of the equation. So the same number of atoms in the products are the same as the number in the reactants. And to start with this, we first make sure we identify the most complex compound, and in this case it's glucose. Sometimes they can also be metal ions, so keep that in mind too. But now it's glucose is our most complex compound that we're dealing with. So do elements such as oxygen or hydrogen, we save them for last, alright, because they're the easiest ones to change the number of atoms for. Okay, so what we're going to do is start balancing the most complex one. So first off, we're going to start with carbon, alright, and we're going to make sure that the number of carbon, hydrogen and oxygen atoms are on each side of the equation. So we're starting with the glucose. So to change make sure that they're balanced, we add a new coefficient in front of the carbon dioxide, and we make that 6, so we've got 6 carbons now on each side of our equation. So moving next, we start looking at balancing the hydrogens, and we do this by adding in a new coefficient in front of the water. Alright, and now we've got the same number of hydrogen atoms on both sides of our equation. And then we leave the oxygen till last, and now we balance out the number of oxygen atoms. And as you can see here, by adding 12, and the reason we've got 12 divided by 2 is because the oxygen is a diatomic molecule, so there are 2 of them. Alright, so we need to take that into consideration. So we have 12 plus 6 from the glucose gives us 18, and that balances out with the 18 on the product side of the reaction. Alright, so again we add the new coefficient in front, and we've got the same number of oxygen atoms. Alright, we can change this to 6 because 12 divided by 2 is 6. Alright, and this is where we make sure that we adjust the coefficients to the lowest whole number ratio. So 12 divided by 2 equals 6. So we're all well and good. So this becomes our new equation here. So glucose plus 6 equivalents of oxygen forms 6 equivalents of carbon dioxide and 6 equivalents of water. Now, one thing you will need to take note of in the future, not so much for this example, but make sure that the charge is balanced on each side of the reaction. And also I would recommend doing a final tally of the number of atoms on each side, just to make sure you've got everything correct. Alright, and as you can see here, the number of carbon, hydrogen and oxygen atoms are the same, and the charge is 0. So it's balanced on both sides of our equation. Make sure you put all the states in for your equations, and take out spectator ions. Not so much in this example, but it's something you may need to think about in the future. And there we have a balanced equation.